will be the paired sample t-test. An educator wants to know if students' math scores have improved over time. Again, the alternative is just restating what the researcher wants to know. The null is just a negation of that. So all I have to do really is copy this, drag it down here, put it in here, throw in the well-placed not or does not, did not, won't, whatever, and then I'm done with the null and alternative. Because I'm looking at changes over time, I'm looking at paired or repeated measures t-tests. My write-up would look something like this again. A paired samples t-test was conducted to determine if the alternative hypothesis were true, i.e. if math scores were improving over time. Results indicated that math scores were not improving. And here are my t and stuff that I would get, my table and my line graph in this case. Line graphs are usually shown to depict changes over time. I could use a bar graph here if I wanted to. I will leave that up to you, and so on. As far as running this analysis, we're going to go back to our small sample HSP data. And see, I have my math2 variable and my math variable. Now, one thing I have to remember is that I had split this data earlier. I don't want to split this data anymore. I want to analyze all groups as all cases. So again, what I would do there is I would go to Data, Split File, click on the Analyze All Cases, and click OK. Now I am treating this whole data set as one big data set. I can go to Analyze, Compare Means, Paired Sample t-test. Let me go through that slower. Analyze, Compare Means, Paired Samples t-test. I put math2 in first because it always subtracts the second thing from the first that I put in, and if I want to see if scores increase over time, right, I will make sure that actually my difference scores or my mean difference reflects that scores are changing over time. And that would be the case if the second time point scores for math were higher than the first time point scores for math. I click OK. I get this output. These are my sample statistics, right? Math 2, 51.1, Math 1, 51.4, basically the same thing, especially given the standard deviation and the standard error, right? I'm not even seeing a third of a point difference. Well, okay, I'm seeing a third of a point difference. I expect, in this case, about a 1.5 if I take the average of these two difference over time. Don't worry about this at this point. I'm looking down here, I see my mean difference, my standard deviation of my different scores, my standard error of my different scores, and then I'm looking over here to draw my conclusion. Because my p is bigger than 0.05, right, I failed to reject the null, and I say that actually no, math scores are not changing over time at all. If I were writing it up then, I would put in my t. Oops. I don't want these things all italicized. Kind of loses the point if this is italicized. Italicize my stats. Again, because I didn't find anything, I don't really have to put in Cohen's d, but if I wanted to, I could, and I would be looking at this mean difference divided by this standard deviation. So 0.347 divided by about 11. And if I go back to Excel and put that in for this one, Cohen's d, right, 0.34 roughly, 10.9 roughly, Cohen's d equals this divided by this. Gives me a Cohen's d of 0.03. And if you remember Cohen's d, 0.2 is the estimate or the kind of the guideline for a small effect. This is a, it's not an effect, which is why we didn't reject the null. But it is super small in terms of its effect size. So that about takes care of it, right? Can do my table and my graph same way as before. If you have any questions, let me know. I'll be checking my email on Sunday evening, I guess, and Monday and Tuesday as well. All right, good luck to you.